Having understood the conditional execution in assembly, now let's move on to another important aspect of programming, which is function calls. Function calls are essential even for small programs because they improve code reusability and they also improve readability of the code. Therefore, most of the ISAs provide some kind of support for making the function calls. So this is how function calls look like in high-level language code. You have a function foo, which takes two parameters, and it can be called from anywhere in the code. So here it's called with two variables and then from a different location again with two different variables. To make these function call in assembly, this is what we need to think about. So how do we pass these parameters? Jumping to a function is easy because you can just write a branch instruction, but how do we pass the parameters? Again, a function can return anywhere in the code depending upon where it was called from. So return is easy in the sense we can just write another branch instruction to return, but we need to know where exactly to return. So we need to remember somehow the location where the function was called from last time. So this is what ARM ISAs provides to make function calls. For jumping to a function, there is a special instruction called BL or branch and link, which is followed by the regular label that each branch instruction is followed by. So what it does is it sets the register R14, which is link register, to PC plus 4. So PC is the address of BL instruction. The sequentially next instruction is PC plus 4 because all instructions are 4 bytes wide. And BL sets the R14 register to the next instruction to this BL itself. And then it sets the PC to labels. So basically it jumps to the label. So this part is common in all branch instructions. This is special to BL. The effect of setting LR or link register to PC plus 4 is now you remember where the function was called from, so that when you are returning, you can use this link register to come back to the place where the function was called from. Returning from function is quite simple. What we need to do is move link register to program counter because link register was set by the last branch and link instruction, so it knows where the function was called from and you can return back to that place. There is no special instruction for returning. You can simply use a move instruction to move the content of LR or the R14 to R15, which is the program counter. So a simple move instruction will take your control flow back from the called function to the calling function. Let's take an example. So this is our high level language code. We have a function add, takes in two parameters, add those and return the added value. Here is the main function. We have two variables x and y, and we call the function add with these two variables. In assembly, we have two labels, each correspond to each of these functions here. Let's first write the main function. So x is a variable whose value is 5. So we move an immediate value 5 to register R0. Then y is 10. We move immediate value 10 to register R1. Then we need to make a function call. And to make a function call, we know the instruction is branch and link. So we use branch and link instruction and jump to this label add, where we write the code for this add function. So this BL will automatically also save the return address, which would be the address of the next instruction here in the link register. So now let's write the add function. So what it does is it just adds these two numbers. Okay, so what we do here is we have an add instruction, add the content of R0 with R1 and replace the result in R0. And then it's just return out of this function. To return, we just move the content of link register to the PC and we are back. Cool. So this is our example of a function call in assembly, right? Oh, but wait, we never passed the parameters to the callee. So here, corresponding to this call instruction, the only thing we did was jump to the function. We never passed the value of x and y to the called function. Also, we never returned the result from the called function. So this add function, it just added the values, placed the result in R0, but then it did nothing else to return this result to the main function. So let's see how we can do that. There are register calling conventions. There are register convention on function calls that are provided by and that are defined by ISAs to help with passing the parameters and to get the return value back. And these are the conventions for the ARM architecture. So to pass the parameter values, we use register R0 to R3. But sometimes we have more than 4 parameters that we want to pass. If that's the case, we need to pass the additional parameter via stack. Stack is a special piece of memory, and we will see what it is and how it is used in next few slides. Okay, so we know we can use register R0 to R3 to pass the values, and the values can be returned to the function in register R0 and R1. Register R4 through R12 are Coley saved registers. What that means is the following. So let's say here we have these two functions, main function and add function. They are doing some calculations and writing values to some registers. So if the main function is writing to a register and then make a function call and the same register is written by this called function, then the value that was written by the main function is lost. When the control comes back to main function, it just doesn't see the value that it wrote. Now it has been overwritten by the called function. To prevent this from happening, there is this notion of Coley saved register and caller saved registers. R4 to R12 in ARM are Coley saved registers. So if the called function wants to write in any of these registers, it first need to save the original value. And then before returning the control back to the calling function, it needs to reload that value in that register so that the calling function or the caller sees exactly the same value as it was before the function call. On the other hand, R0, R1, R2, and R3, these are caller saved register. So if the caller or the calling function wants to preserve the value of these registers after the function call, it needs to save them and restore them itself. So it saves the value of these registers before making the function call and restores it once the function returns. Then R9 and R12 are special purpose register. Their function depends on different implementation, how the implementer decides to use them. Okay, so based on this understanding, let's go back and see if our code was fine. So what we understand from here is that the parameter needs to be passed in register R0 to R3, and the returned value should be in register R0 and R1. So if we go back, that's exactly what we did. Our values that we wanted to pass were in register R0 and R1, and the result was in R0. So this piece of code is actually correct. We are passing the values through these two registers and we are returning the result through register R0.